This video is going to show you how to build the acetyl chloride molecule and draw the proper line structure with 3 dimensions. First thing I'm going to do is build my acetyl chloride. CH3 connected to another carbon. I know that chlorine can only make one bond. I'm going to put my chlorine on first. And then in order to satisfy both my oxygen and carbon, I'll have to double bond my oxygen. Here is my acetyl chloride. If I were to draw this, it would look like this if I didn't do any sort of geometry. This is flat and 2-dimensional. The issue is that we want to communicate that our line structure is in 3 dimensions because molecules exist in 3 dimensions and they're not flat. So how do we do that? The first step is to find the plane that contains the backbone of the molecule. I look at my molecule and I find the line that connects the most amount of atoms. So if I look at my molecule, that would be this one. 1, 2, 3, 4 in a line. That is my backbone. I drew a line here to help me. I'm going to put my backbone on the line, and from this angle you can see that in the plane, that flat part is my chlorine, my carbon, my oxygen, my carbon, and my hydrogen here. They're all flat on the same plane in space. That's the 2-dimensional part of it. The next step is to remove my hydrogens that are coming out of the plane. Now I'm going to draw this with proper geometry. Here I have the lines all at 90 degrees. All of the atoms are 90 degrees or 180 degrees away from each other. If you look at your molecule, you can see that that's actually not the angle of the bonds. So we need to draw the angle of the bonds correctly because the angle of the bond is very important. So I'm going to start with chlorine. Then it goes up to carbon. That goes straight up to a double bonded oxygen, down to another carbon, and then up to a hydrogen. You can see that this is pretty much the same geometry that I'm seeing in my molecule. Next step is to replace my hydrogens and draw those on my molecule. You have to communicate that one hydrogen is coming forward in space, that would be this one, and one is going back in space. And they are on the same plane going forward and back like this. They're one right in front of the other, and they are perfectly bisecting this angle here. I'm going to draw a dashed line, and this is just for a guide for me. This is where my hydrogens are coming out of my carbon, forward and backwards. The way that chemists communicate forward and backwards in space is by a dash and a wedge. Wedge is forward and it looks like this, a filled in triangle. This is a wedge. And a dash line that makes a triangle as well. This goes back in space. So I want to get them as close to this line as possible to communicate that one's going forward and one's going back, and they're both facing down. They're both going down and away from the carbon. So the proper way to do that is to draw kind of one off to this side. This is my forward facing hydrogen. The small part of the wedge always goes towards the central atom. And then next to it, right next to it, I draw my wedge. Like that. So this one's going forward, that one's going backwards in space, just like my model here. It's not proper to draw it going up because that would indicate that this hydrogen is going like this, and that's not what we're seeing. It's going back and down. So you're drawing them out of space. Whenever you have molecules that are not in the plane of the backbone, they need a wedge or a dash to indicate that they're going forward and backwards. When you're using pencil, you can erase this guideline, and that is your final molecule. It's important to draw things in 3 dimensions because the 3 dimensions of the molecule can change how they interact with other molecules, and that is where we are moving towards. All right, you're going to work on doing this on your own now.